We selected Haggstrom by C418. We originally started with a long list of songs, and we voted on those to narrow it down. Then we came to a consensus on Haggstrom because it translates well from piano, it's not too fast, and it doesn't have too many notes.
The next step in the process was deciding what we wanted to do for our design. Initial ideas included a music box-like design to strike the chimes or building motor hammers to hit stationary chimes. However, we ended up deciding to use a rack and pinion track to move 4 solenoids horizontally, allowing us to hit any combinations of notes we wanted. To support the chimes, we would use a combination of string and a wooden dowel along the shared note points.
So this is the rack and pinion design. Initially, we thought of having 2 motors with gears attached to them, laser cut, and we'd have it basically connect to this rack here, which was also laser cut, so they'd essentially be on a track. And then we would have 4 different solenoids attached to the track, so when we wanted to hit different notes, we just moved the motors, which moved the pinions, which moved the rack, which allowed us to hit every single type of combination of note. Initially, we had 2 motors rotating at the same speeds to move the rack and pinion track, but we found that because the 2 motors have different gear ratios, it's difficult for them to rotate at the same speed. So instead what we did is we're using 1 motor and 1 wheel and joint.
Alright, so on our original ideas, we dealt with a lot of bowing when we tried to insert the chimes into the frame. We tried to attach it with zip ties and string and stuff like that, and it was bringing it in too much. So to combat that, we added poplar supports over the top of the machine, which keeps the walls of the frame outwards. In addition to that, we got rid of the dowel because we were struggling too much with it and it was being a pain. And instead of string or zip ties, which weren't working, we used pipe cleaners. And those hold the chimes up very well, and they also allow for more resonance.
When testing the machine, we realized that the motor moves forward faster than it does backwards, and it would move inconsistently backwards at different speeds. So we realized that we need a potentiometer to be put in place to know exactly where the rack is, instead of just having it a timed delay to turn the motor off and on.
For the code that runs the machine, we decided to organize the code measures. Within our song, there are 16 measures, so we made a function for each. Within each measure function, there are smaller functions dedicated to playing the notes. Each note has a different rack and pinion position and designated solenoid to hit the note. For example, if we want to play last stanza, the machine would move to a position where E can be hit, use the designated solenoid, waits the length of the note, in this case a quarter note, and then moves to a position where G can be hit, and so on.
Our chime machine mainly consists of stationary parts such as the frame, supports, and chimes, but it also has moving components, which are a rack and pinion gear that is moved by the motor. A potentiometer is also moved by this gear attached to the motor so that we know what positions our solenoids are in at all times. These solenoids are attached to the rack and shift strictly left and right underneath our chimes. Our current setup for holding the chimes in place is a chime going through the hole in a plywood held up by a pipe cleaner. The problem with this is that the holes are kind of small and sometimes the chimes rest against one. An improvement for this would be increasing the height of the holes. This would allow the chimes to be held perfectly in air by the pipe cleaners, and this would greatly improve the resonance of them. Another improvement we could have made is this is what we currently have, and it is our potentiometer is held down by a zip tie. Since the hex nut on it does not move, we could have made a plywood piece that it slots into, and then it is held in the back by poplar.